This course will introduce you to SCADA, forensics, and incident response. You'll basically gain a basic knowledge of what SCADA is and the terms used when it comes to SCADA and embedded systems. You'll learn about the architecture generalities and both the problems and what you'll be looking at when you do a incident response or forensic on a SCADA system. So what are some of the general terms? Where SCADA means supervisory control and data acquisition. Two other terms that you're going to see when it comes to SCADA systems are a DCS, which is distributed control systems, or ICS, industrial control system. In a couple of slides you'll see some diagrams, but a typical SCADA system is an infrastructure mainly comprised of both control centers and field sites. Think of it like the 911 center for the police department, and every car out in the field is a field site. The field sites will have programmable logic controllers, or PLCs, and or remote terminal units, RTUs. Inside the control center, they'll have human interfaces, HMIs, a database management system, and a database which records everything from logs of what's occurred to what commands were sent out to the PLCs and RTUs. And it also receives back data from the field devices that may be sending information such as the red light's on, the green light's off, or temperatures, fluid flow, wind speed. All these things are available from a PLC to an RTU to be sent back to a communication line. So basically, a remote terminal unit, or RTU, will send information by different communications, media, or channels, like a satellite, a wide area network, or by a radio system, a cellular system, microwave networks, huge WAN networks, some of the new mesh networks that are basically wireless networks, but they're only anywhere from a quarter mile to a mile in length. Items like that. Here's a typical system that you might see RTUs and SCADA used. This is an example of a power grid system or a smart grid system where you have service providers. The operations center would have the human interface, and out in the field, such as the substation or the transmission lines, or even at the homes, you would have the RTUs reporting back information as to how much electricity is being used, what the flow is, if there's a blackout. Here's another graphic view of what a typical SCADA system would look like, and the same thing again with a power grid system. You'd have the RTUs out in the field and the PLC commands reporting back on the power grid itself. And then back at the substation, you would have commands going out talking about switching electricity, reducing the current flow, etc. As you can well imagine now that a SCADA system like that would be a target for anything from terrorists to just hackers trying to cause problems. Or maybe a mistake was made and they're trying to figure out where the mistake is. All those things would have to be done through a SCADA forensics, which is reviewing logs, reviewing systems, seeing if original code was changed or not. So what are the challenges to doing that in a forensic? Well, there's unknown embedded operating systems. In other words, it has a special unique operating system for a specific RTU or PLC. You may have unknown proprietary operating systems, ones that aren't like Microsoft embedded Windows 7 or CE. It'd be something somebody wrote, Joe Blow operating system running on an RTU. Normally these things are put in and they're extremely old. They were put in back in the 60s and 70s and 80s, and there's no network layout, no knowledge about what the network looks like. All they know is if it's not broke, don't fix it. And it's very hard to get logical access to these devices. Most of it is hands-on, directly on the device itself. And there are many unique systems in the field that were made specifically for a need at the time that the RTU or PLC was purchased. And there's very little tools to assist you with forensics on those items. So we're back to creating our tools on the fly on a lot of these. Another problem is they weren't engineered with security in mind. No one would think that. Why would somebody get into the electrical system? They were not engineered with remote connections in mind either, with security for the remote connections, and many are 15, 25 years and older. New devices have some built-in security, but even those have vulnerabilities that are never kept up or updated in a proper time frame. 90% of all the systems in the field are still of the older type that have no security in mind. So now that you're totally paranoid now about the electric system and SCADAs, let me tell you about some of the things that would make it easier for you. Some of the newer systems have something like a customized Windows CE 6.0 involved. Although there's vulnerabilities they probably have not patched, that still allows you to use some basic Windows software and tools to do an examination on those types of systems. The things that you will run into, though, is that they will have a keyboard or mouse, and they will require a login password. You must try to get those if possible. If not, if you're able to image, because they're an older operating system, there are bypasses around things like a login password. The key to most incident response and or forensics on SCADA systems is knowing what the network layout and the general layout of the system is itself, and how an attacker might go into it. Here's an example of the traffic light system. We have the traffic lights that are controlled by RTUs out in the field, and we have a PLC, and then we have a Siemens S7 PLC controller ahead of it. They'll have that attached to a watch table on a system back at the main control unit, or an OPC server, where they also have storage. Those are the logs that you must get, and take a look at the output of those values and compare those values to a normal traffic light to find out if a hacker has changed the values, when it was changed, and what consequences occurred because of those changes. You can also gather this information by having a network packet capture, or maybe they do, and they have that stored just in case something occurs. Those are the questions you need to ask of the people running the system when you first get to an incident response on a SCADA system. Here's another example of a SCADA network. As you progress in incident response or a forensic, it is best to try to diagram something like this so you can get an overall picture of how the SCADA network operates, which will also give you an idea where a hacker may have been able to introduce themselves in to play around or screw up the control devices, the PLCs, etc. Here's another example of what the PLCs or RTUs look like. On the top left, those are PLCs. As you can tell right there in the center, there's a RS-232 port right there, which you can communicate directly to the PLC. Those kind of cases are easy to get an image of the memory that's inside the PLC to see what occurred in its programming. On the right is another example of a remote PLC that has this attached radio interface. That's the little black line on top of the box. In the bottom left-hand corner is a set of communication devices. Even those can have PLCs or RTUs inside, for they're communicating back via microwave to a main control unit. And then, of course, on the right is a remote terminal unit, or RTU. But each one of those cards is an RTU. So when you're doing a forensic on something like that, you're going to be doing a pull of memory on each individual card. And you'll have to record both what card number it is, and then from a diagram, figure out what that RTU controlled. And yes, you may be even called to go into a home such as this that has this entire home system, heating, air conditioning, appliances, lighting, security system, telephone system, internet system, all controlled by a main control unit within the home. That's considered the units out in the field, the lights, like the LED lights and the heating units, those would be the RTUs and the control units. Whereas you'd either have a central communication wireless system that would be the MTU, or the main control unit, someplace in the home, or it may even be out in the cloud. Everything reports to the internet out to the cloud. So you'd have to figure out from the individual units where you need to go get the logs to find out what occurred. On the bottom photograph, that is an image of a typical master control unit of all the things that are involved in a SCADA unit This one is for a wind turbine. Adding to what I just talked about when it came to home automation, I want to bring up a new item that's hitting the marketplace. And it's referred to as a smart home hub. In the marketplace today, we have two people who've entered that rather large field. They expect it to be a $14 trillion market by 2022. And that is the Amazon Echo and the Google Home. Echo is more locally known as Alexa. It is voice activated. Anywhere in the house you can be, and it can hear your voice pretty much. And if you say Alexa, the blue light comes on, and then it will do things. Everything from turning lights on or off, ordering an Uber vehicle if you would want one, your alarm systems, the front gate, the sprinkler system. All those things are going to be run by a home automation system such as the Amazon Echo or the Google Home. They even have dog feeders like the Petsy that you can be away from your house and you can remotely access and feed your dog or your cat by just a touch of a cell phone. These things will also be something that you'll be looking at and trying to figure out what evidence or data could be contained in these items, such as the Echo. Are there log files? Where are those log files stored? If somebody accesses them, is there a tracing of that? Is there a tracing of what it did in as far as changes? Maybe the alarm system was turned off by the burglars as they got to the house because they knew there was an Amazon Echo there. They could see it on the Wi-Fi system of the house. Did they turn off the Wi-Fi system? Did they access the Google Home and order items from a business so that they can get money from a overseas account? I'm a business, I'm selling multiple printers, and you order a printer from me for $100 that is delivered, but you never really ordered. Now think about that times 100,000 homes with Google Home. How much money would be flowing into a business? And how many people would actually catch that? Would they catch it if it was only a $10 payment? For music, would they remember that they bought music from some outside the Google realm? Those are the types of things that you may be looking at in the future when it comes to doing forensics or investigations. That's why today you need to start looking at what is the Amazon Echo or the Google Home and where are those log files. Luckily for you, in class 3 and 4, we'll have lectures that covers specifically home automation units like this. The advantages of trying to figure out what the network topology is on a system. Here's an example of you have layer 0, which are the PLCs and control units out in the field. Layer 1, the controlling LAN. Layer 2, the supervisory LAN. Most people would think that you can control those RTUs and get access to the system by just breaking into the local HMI system section of the diagram. But in all reality, if you had access to layer 5, 4, or 3 by hacking into those systems, by sending an email and getting control of somebody's remote desktop and then getting into those systems, you would have access all the way through to the end to the PLCs. So you see an investigation into a compromise of a SCADA system can be wide-ranging and very complex. Here's another example, just to make you think a little bit further, that in this kind of communication network, the SCADA system goes through a switch and is controlled by a workstation, a server. But also, if you can compromise the printer, you can still get access to the SCADA systems remotely. You should now have a basic knowledge and understanding of what an ICS and SCADA system comprises, and what you'll need to consider when performing a forensic examination or incident response in such a system. Later on in classes 3 and 4, you'll have hands-on experience in looking at the logs and the output from a RTU and reporting devices in the field and logs from a human interface or archive log.